Okay, first part is called center of a circle. Okay, so if you hear me say somebody's center, know what I'm talking about. If the problem on the paper says find the area of the center, know what they're talking about. Okay, a center is the region between two radii and the arc of a circle. Think of it as a slice of pizza. So that shaded region that you see right there, there's a picture right there. Make sure you draw it as well. You don't have to write slice of pizza unless you really want to. Just make sure you get the real geometric definition. But you will be able to tell me the area of that little section right there. Okay, or the other part. Okay, part. Everybody got it? Alright, here's how you do it. There's an angle that goes with that central angle, okay, which also happens to be the same as that one. Okay, so let me put X on both of those. That angle you want to put over 360. Right there, that takes care of the portion. Then all you do is multiply it by the area of the circle, which that's what you did yesterday. Okay, so real simple formula. X over 360 times pi r squared. This whole thing is not on your formula chart. The only one that is that. So you have to remember this first part. Okay? So X over 360 times pi r squared will get you the area of the center. So draw this symbolic one first, and then draw the formula right after that. That's how it goes under. Alright, everybody got the formula? Okay, let's practice using that formula. We're going to leave our answer in terms of pi, and then we'll also do the estimate. So if I have to find that up there, all we're going to do is take that central angle, which is 60. So put 60 over 360, and then times it by the circle formula, pi 3 squared or 9, right? Okay, you can't leave your answer like that. You have to simplify it all the way through. So you should be able to recognize that the zeros can cancel out. Right, that's a quick way to simplify fraction. And then, what's that? Well, let's think about the fraction. And then that's 9, and then pi. So really, what fraction do you have? What's the fraction that you want? What? Make it one fraction, yeah. What? 9 and 1/6? No. 9 over 6. Okay? If you can't do that in your head, imagine this in fraction. How do you multiply fractions, y'all? Just straight across. Those are the easiest ones. You have A over B times C over D. Multiply that with that and that with that. Do not cross multiply because there's no equal sign in between. So you have 9 over 6 pi. You can't leave it like that either. What do you got? What do you got? What? What is it? 3 over 2 pi. Okay? If you have to write that as 1.5 pi, that's okay also. Okay? That's a fairly simple example. Okay? That would be your answer in terms of pi. Inches squared. What is the estimate of that? Let me put that in your calculator. Say louder, okay? There, reminder homework. You get to choose if you rather leave it in terms of pi or you rather put it in decimal form. Okay? Only on the ones that don't specify. There's some that actually specify even in terms of pi. Okay? All right, let's go to this next one. Brighter, focus. Okay. Bring it, focus, over there. Find the area of the shaded parts, the brown. There's that way too. Two steps down. Okay, tell me the value of x, writer. What's the value of x? So we're going to plug into the formula. What? You don't know. Olivia, tell me the value of x. Huh? No. Tell me the value of x, Jordan. Oh. Yeah, you can. What? 270, right. Okay, so if we stick to the formula, it'll be 270 over 360. Now, some of us can probably figure out real quick, since this is 90, how much is that? Like, just real quick. 3/4, right? Okay, because if you reduce 270 out of 360, that reduces to 3/4, okay? So, something to think about. 90, 90, 90, 90. These are all called what, y'all? Quarters. Okay, so this is like 1/4. Okay, obviously that's a half. Okay, like the semicircle is just half of a iron square, which y'all did that already. And so if you have 3 of them, that's like 3/4. Okay, so I'm going to just go ahead and reduce that already to 3/4. Then you have 5. What's our 2 squared? Okay, well, what's 2 squared, y'all? 4. What happens next?
So x is the shaded area.
Yes, multiply across, but what can you do even a little bit more quicker? I think I heard somebody say it. Huh?
Cross simplify towards the way.
Cross simplify what that is? Cancel out the 4, is that what that means? Yes. Cancel out the 4. See that? We have a 4 on the top and a 4 on the bottom, they just cancel out. If not, multiply across, you get 12 over 4, and we're going to 4 over 12. 3, so see how they just cancel out? So 3/5 meters squared is correct. What's the all right, next one. Next one's called a segment of a circle. Okay, so a segment of a circle obviously looks like that. Definition would be the region between each chord. The chord we learned way back in chapter 1. That's where you've got a segment and the endpoints are on the circle. So it's the region between the chord and the arc. So this shaded part right there, you'll be able to find that area. Alright, ready for the definition? I mean the formula? This one also is not on your formula chart, so you'll have to remember it. Okay, let's go over the symbolic part first. What you'll do first is you'll find the area of the sector, that's what we just went over, we just practiced. Okay, that's first. Find the area of the sector. Then subtract the area of the triangle, which is that right there. And then that'll leave you with the area of the segment. So actually draw out the little symbolic picture. Draw that out first. Okay, so what was the formula of this one just a second ago? Alright, so that's going to go first. What's the formula of that thing? 375 divided by 2. That's all that is. So remember, just little process. Find the area of the center, subtract the triangle, and then that's your answer. So we want a formula format, and so we're doing 60 times pi r squared minus base times height divided by 2, or 1/2 base times height. You do not have this on your formula chart. The only thing you have is pi r squared. So you'll have to memorize this process. Is everybody write down the formula?
Thank you.
How about now? Okay, the last one is called an annulus. Okay? An annulus is the easiest one of the three because all it is, it's like a tire. Okay? So we're going to know that. Whatever you're going to call that. It's the region between two concentric circles. Last semester in chapter 1, we talked about what concentric circles are. What do they share? The center. They have to have the same center. If they don't, then there's another way you'll have to figure this out. It's something like this. If it's over here, that's different. Okay? Because the center is the big one is probably about right there, and then that one's there. Okay? So you just have to do it the other way. It's pretty easy still. Alright. You'll take the area of the big circle and minus the area of the little circle. That's it. Okay, kind of the same concept that I always taught you with the shaded part. Find the area of the whole thing, and then subtract the area of the non-shaded. So there's really no way to write that formula out, so I just drew it like that. Or maybe put this as capital R. Big pi r squared by big pi r squared. This one's the easiest of all three. Second one, a little more challenging. Center. Halfway. Okay, got it? Okay, practice just those twice, and then you can have the rest of the time to work on the assignment. So here we're going to find the area of the shaded segment. Okay, so that's the segment of the circle. So what is going to be the value of x, David? What? 90, correct. 90 out of 360. What's a real quick fraction for that? So you can automatically write that down. Okay, what's R, y'all? Okay. All right, there's that part right there. Then we want to do what? Subtract something, right? So put a minus next. We're going to subtract the triangle area. So base times height, divided by 2, or 1/2 base times height. What's the base? It's the height. So for a right triangle, it's the same. These are congruent, they're both called what? They're both radii. So that stays the same. Alright, so 6 times 6 divided by 2. And then last thing, you need my answer. Okay, so let's do a lot of simplify. We're going to leave our answer in terms of pi first. So what's this and this combined together? Very good. 36 divided by 4? 1, 4 times 36. 5. So 4 goes into 32. 9. Right? You see it up there? A little bit better? Alright. Minus, what's that number? Can you subtract those two? No. If you were told to leave it in terms of way, you stop there. 9pi minus 18 square root. Okay. Give me the approximate area. Just punch it in your calculator. 2 what? Alright, the last one, give me big R. Tracy, what's big R? 7. Minus, what's little r, y'all? Would be RB6? Does it say a different number on them? No. That's 3, that's 4. What's 4 plus 6? Alright. What time start off? What's 4 start? Can we subtract these now? Yes, but they're like terms, like 15x minus 9x. So that's your answer in terms of time. You can put any decimal you want. Alright, pretty easy. Okay, the last two you have on there, let's just kind of review that. What's the area? Let's just do one. The area of one of them.
X squared plus 9x plus 18.
Okay, so they gave us the area of one. Now you have to find what W is and what L is. So it's kind of like going backwards. You had this one on your quiz, but they gave us these, so we had to find that, and y'all forgot how to do that. We did that straight on those. Okay? So they want to do it this way also. The easiest way to do it is to work with the box method. Our algebra teacher teach y'all the box method? Okay, so let's do box method. You can do the same with FOIL. Neutral, fine, using FOIL, use the FOIL then. Okay? So, we're going to use two terms, okay? This is x squared always, the first term. This last term is always the last one on there. We don't know what each one of these is, we just know that both of them add up to what? Negative 9x, right? So with that, just those two, 1 times 1 gives you x squared. Okay, here it might take you a couple tries, okay, but you can also think about these two boxes. 1 times 1 gives us 18. 6 and 3, okay, 9 and 2 also works, right? So let's just say y'all pick 9 and 2 first, okay? Just say y'all pick, okay? This is 9x, and that's 2x. It doesn't go up to negative 9, so then that's when you kind of say, well, those are probably not it. Even if you were to make one negative, they don't, like, still add up, right? So we got 6 and 3. Negative 6 and negative 3. So 2 negatives make a positive, good, so that's negative 6x, negative 3x, that adds up to that. So there's your length and there's your width, or vice versa. Okay? You can switch them up. So x minus 6 is one, x minus 3 is the other. Okay? If you're using FOIL, you just say to yourself, or set it up like this. Okay? And then put like kind of blanks right there and tell yourself what times what gives us this first one. Okay? First term, O-L,